uniform circular. Kishore, call to Lingesh. Uniform circular motion.
Yes, sir.
Okay. So let's start. All of you. Yes. So please remember, nothing is there. It's very simple actually. So nothing. When the body is revolving in a particular track, then what is to call? That is only called as, all of you,
Distance.
circular motion.
Circular
That's
motion.
right. When a body moves in a circular path, when a body, for example, I am taking a particular body, is keep on moving in this path, then the body is said to be in what motion? All of you, circular path around a fixed point, then the motion of the body, is called circular motion. Is it okay, everybody? All of you? Now, here two things you have to be very careful. It has to be travel in a circular track, but around a what point? Everybody, that is very important. Around a what point, guys? Fixed point.
Fixed point.
For example, let me consider now, Mr. Kishore is standing here and he is holding a certain kind of ball by tying the rope, and he is holding with his hands. Is it okay, Mari? You might be noticed this one. Yes or no? All of you? So now he is keep on rotating the ball. So now what will happen? Who is the fixed point here? Can you tell me? Now he is keep on rotating the ball. Ball is keep on revolving in a particular track, and again it is keep on revolving this ball. Okay. So now you tell me, who is the fixed point here?
Shailesh.
Yes, Mr. Kishore. So the circular path, when a body moves a circular path around a fixed point with constant speed, all of you remember, speed is what? All of you, constant speed. Then constant speed, then I can say the motion of the body is what motion? All of you, uniform circular motion. Why it is
Circular
uniform
motion.
now? Because of what speed? Because of constant. It is uniform circular motion. Means the body is traveling. Constant speed means, what do you mean by constant speed? We all studied. Constant speed means, what is that? Body is traveling equal distances. Speed. Even in circular path also, sir, it's not in a straight line. How, sir, you can say? Circular path also, it is uniform circular motion. Means it is traveling with a constant speed. Means in the sense of body is traveling what distance? Equal distance in, everybody, equal
interval of
intervals of time. So that is what you have to remember. Is it okay, everybody? So if you take Mr. Kishore is rotating, understanding a ball which is tied with a thread, and he's basically that process. Even we people see, when I am in childhood, I used to do to throw the stones and to throw the ball for a longer distance. I will tie some kind of a rope to that and keep on rotating, and suddenly if I leave, it will travel very long distance. Have you all experienced anybody, you people? Anyone tried like that? Yes, please. So,
yes, sir.
Yes, Mr. Kishore is actually tied one rope with to some ball or some kind of small stone. He tied a ball tied to a thread, and he is vrilled in a circular path. Vrilling, we can say. What is the name of that word which is called as? Vrilled. Means circular motion. Continuously if he is rotating, that is what we can say whistling. Vrilled in a circular path, then it is called as circular motion. Understand? So when a body moves in a circular path around a fixed point, so who is the fixed point here? Mr. Kishore. Then that is called as, what is to call? Circular motion. Now, if you go to the Gandhi Park or if you visit any kind of park, you might be all experienced it. So a certain kind of system, I will draw it now here. You see that it will be like a disc. It will be like a disc and it will be having a particular trace. So a boy or girl will stand here and it will be keep on rotating. Have you all noticed it? Yes, please. We used to call it as
Sir.
merry-go-round. What is that called as? Merry-go-round. Do you remember, everybody? A person will stand and it will be keep on rotating. Yes or no, guys? Please respond. All of you.
Yes, sir.
Yes, sir.
Yes. So that is what. So this is also example of what motion? Because it's a fixed point. The pole which is present here middle is actually a fixed point, and the path, the boys keep on rotating in the same track. So that is why along a fixed point he is rotating. So that is why it is called as. We used to call it as what? All of you. It is a circular motion. Yes or no? Please respond.
Yes, sir.
And
Yes, sir.
now
Yes, sir.
Mr. Kishore is rotating or whirled the stone in a circular path. Now you tell me, if anybody wants to move in a circular path, is it need external force or not? If it wants to travel with a constant speed, is it
Yes,
external
sir.
force is needed or not? That is what my question. Anybody?
Yes, sir.
All of you, please respond. Yes.
Yes.
Yes. So that is very, very important. So please make it. An external force is needed to move a body. An external force is needed. An external force is needed. So have you all visited Gandhi Park? How many of you visited here Gandhi Park? I want to know. Anybody? Yes. Backside bike running. Have you noticed it? That Mike they'll keep on saying backside wanga Mike rotor. Then the bike rotation bike rotation and mother they'll say. Have you noticed it? All of you? Yes. Please respond.
Yes, sir.
So that is also what example of what motion? That is also we can say
Uniform circular motion.
uniform circular motion. Understand? And is it automatically bikes will rotate? That is only we can say merry-go-round. Okay, merry-go-round. So is it bikes will rotate automatically or they need external force? They are providing external force with the help of whom? Electricity. Yes or no, guys? Yes, please
Yes.
respond. So
Yes, sir.
if you want to rotate a body with a constant speed in a circular track, it needs an external force. External force is needed to move. Please write. To move a body. Agali, are you understanding? To move a body on a circular path with what speed, guys?
Constant.
With constant speed. Understanding? So then only we can say if you are moving with a constant speed only, then what we used to call that circular motion is called as. Yes, please.
Uniform
Circular
circular
motion
motion.
is called as uniform circular motion. Do you all understand, everybody? So this external force which is needed to move a body on a circular path with constant speed, that external force only we used to call as centripetal force. What force we used to call, everybody? We used to say
Centripetal force.
centripetal force. Understanding? So means if the centripetal force acting on a body which is moving in a circular path is removed, all of you remember, then the body will never or no longer moves in a circular path. For example, observe very carefully. As Mr. Kishore is whirling a stone in a circular path, continuously he is whirling. Now, suddenly he dropped applying the force. Then what will happen, guys? This ball or stone, is it will be here? Suppose Mr. Kishore is stopped applying the force at this point. Then at this point, the stone will. Is it possible to move in a circular path or it will go in a straight line? Everybody. Yes, please. If Mr. Kishore is stop applying the force, then what will happen, guys? Here, is it possible to move in a circular path?
No, sir.
No.
No, sir.
So at that point, wherever he will stop the force, at that point it will travel in a straight line. Is it okay, everybody? Understand, everyone? So you might be experienced
Yes,
those
sir.
who are thrown the stone or ball by tying some thread, continuously rotating. Suddenly, if you stop applying the centripetal force, then the ball will travel in a straight line. For example, let me take all of you. Now, always we all know sun is the center of the solar system, and imagine the earth is revolving around the sun. Now, Earth is always traveling in a particular path. Why, guys? Anybody? Because sun is exerting the force towards to it. That force only what we used to call external force. What is that called as? Which force it is? We used to call as
It's
centripetal.
Centripetal
Now,
force.
now Earth is keep on rotating. Now Earth came here. Here also force is acting towards to the center. Yes or no, Lingesh? Earth is here. Here also force is acting towards to the center. Earth is here. Here also force is acting towards the center. Earth is here. Here also force is acting towards the center. So that is why Earth is continuously revolving in a particular track. Will you all accept with me? Please respond. All of you.
Yes, sir.
Now,
Yes, sir.
if suddenly the sun will stop applying the force, suppose when the body is here, be very careful. When the body is here, now Earth is here. If the sun will stop applying the force when the Earth is here, now Earth will go in a what direction? Is it Earth will follow the same path again, or at this point Earth will go in a straight line? Everybody, what will happen? All of you. Yes.
It will go on a
Go in
straight
a
line.
straight line. Now, for example, Earth is here. At this time, sun will stop applying the force. Then at this point, Earth will go in a what line? Everybody,
Straight line.
straight line. If Earth is here, at this point, sun will stop applying the force. Then from this point, it will travel in a what direction? Everybody, straight line. Understand, Mari? Sanjay? If suppose Earth is here, at this point, if I stop applying the force, then body will travel in a what line? At this point, it will travel in a straight line. Understand, everybody? Please respond. So at every point of a circular path, the centripetal force is acting towards to the what? Towards to the what? Everybody? Towards to the center. Understanding? So as soon as the centripetal force is stopped at any point of a circular track, be very careful. At that point, body will travel in a straight line. Is it okay, everybody? Please respond. All of you. Yes?
Yes, sir.
Okay.
Yes, sir.
So whenever, always remember, centripetal force is acting in a circular path. Always the centripetal force is acting from any point. The centripetal force is acting towards to the what, guys? Towards to the center. If the centripetal force will stop at any point, at that point, the body will travel in a straight line. So that is only ways to called as. If suppose here the force is applied, the applied force is stopped, then at this point, the body will travel in a straight line. So,
So that sun only knows are producing the centripetal force.
yes, Mari, what?
So the sun only knows are producing the centripetal force.
Yeah, that's what. If the sun will stop the force, applying force on the earth, then earth will fall into the straight line. It will go in a travel into the space in a continuously straight line. Understand, Mari? Same
Yes, sir.
like, suppose if the Kishore stop applying the force here, then here the stone will travel in a straight line. If the Kishore will stop applying the force when the ball is here, then at this point, ball will travel in a straight line. When Kishore stop applying the force when the ball is here, then at this point, it will go in a straight line. Do you all understand, Mari, what I'm saying? You can try, everybody. You can try a small bit of chalk piece, tied a long rope, and you try to rotate it, try to leave it. If I leave at this point, it will go straight line. If I leave at this point, it will go like this line. If I leave at this point, it will go in this straight line. If I leave at this point, it will go in this straight line. Is it okay, Wa? Please respond, everybody. Yes. So
Yes, sir.
everywhere I am trying to act force towards to me. That is what the force exerted by me, we used to call as what force? Everybody. We used to call as the force acting towards the center.
External force or
Centripetal force.
Centripetal force. So if I stop applying the force at this point, then from that point, body will travel in a straight line. So this straight line only we used to call as, be very careful. If I take a circular track, a perpendicular line passing through the circle by touching only one point, we used to call it mathematics. Who is that? Anybody? What is that point we used to call?
Tangent.
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 And theta.
Understand, all of you?
Tangent.
Suppose if the body stop applying the force here, at this point it will go in a what line? Straight line. Again, I am drawing a what actually? Yes, please.
Tangent.
Tangent. Understanding? And suppose here I will stop applying the force. At this point, it will travel in a what? It will go in a straight line by drawing the tangent. LMA clear, everybody? Yes. Please respond. So that is
Yes,
what
sir.
is very, very important. So the force which is acting towards to the center, what force we used to call as? All of you?
Centripetal
Centripetal
force.
force.
Centripetal force.
So
Centripetal
as soon as the centripetal force is stopped applying, so at that particular point, instead of moving in a circular path, the body will go in a what line? The body will go
Straight
along
line.
the
Straight
no,
line.
you should
Straight
not say
line.
straight line. The body will go along the what line? Tangent at that point. You are
Tangent.
understanding? Tangent at that point. So instead of going in a circular track, it will go in a straight line from that particular point. That is why we can say at every point in a circular track, the centripetal force is acting towards the home. The centripetal force is acting towards the center. Understanding? It is directed towards the center and along the radius of the circular path. If the force is stopped applying in this, then a body will falls into a straight line. It will goes along the tangent at that particular point, wherever the force applied is stopped. Is it okay, everybody? Are you all clear? Please respond. Yes. That is what.
Yes, sir.
Right.
sir.
What you have written? Then external force is needed to move a body in a circular path with a constant speed. That force only what force we used to call as? Everybody. That force is known as
Centripetal force.
Centripetal force or
centripetal force. Yes,
external
right.
force.
It means if centripetal force acting on the body moving in a which track, guys? Moving on a circular path. Moving on a circular path is removed. Circular path is removed. Then is it possible to move the body in a circular path, everybody?
No,
Yes,
sir.
No, sir.
then the body will go, then the body will no longer move on the which path, guys? Move on the circular path. Instead, it will go what, everybody? Instead, it will go along the what? Along the
Tangent.
tangent
Tangent.
at the point on the circular path. On the circular path at that instant. At that instant. What do you mean by at that instant? If Kishore will stop at this point, at that instant, tangent. If at this point, tangent. If at this point, then at that point, we have to draw a tangent. Do you all understand, everybody? That is the meaning of at that instant. Is it okay, wa? Yes, please. All of you. Yes.
Yes, sir.
Yes, sir.
Now, so from this we can make conclusion. At every point of a circular track, the centripetal force is directing towards the what? Everybody, very, very important point. Yes, please. It is directing towards the what? Center or out of every point on the circular track, circular path. Centripetal force is acting towards the what, guys? Directed
Towards
towards the what?
the
Center. Understand?
Center.
yeah.
The centripetal force is directed towards the center and along the radius of the circular path. Is it okay, everybody? Are you all clear? Agalya, Sangamitrai, Alpin, that is what you have to remember. Any doubt, anybody can ask me. Is it okay, guys? Mari?
Yes,
Yes,
sir.
that is what. Any doubt, anybody can ask me. Okay. So now we can make examples. So can you tell me example of circular motion? I already made so many examples. So now can you tell me examples of circular motion? Just now I told Earth is revolving around the what?
Sun.
Earth is revolving around the sun. I can say
Sir, and a boy is swinging
yeah, right. Motion of the earth around the sun. Around the sun. In what motion? Uniform
Circular.
Circular motion.
uniform circular motion. That is what you have to remember. Okay, next. So here, to make the earth to move continuously in a particular path, what force is needed? What force is needed?
Centripetal
Force.
force.
Understanding? It is centripetal force is needed for the motion of the earth around the sun. That centripetal force is provided by some force, which is called as G, acceleration. Acceleration due to gravity. Understanding? So acceleration, gravitational force only makes the earth to move around the sun continuously. That gravitational force only, what force we used to call as? Everybody.
Centripetal.
centripetal force.
Understanding?
Centripetal external.
So yeah, centripetal force. The centripetal force acting always towards the home. Everybody.
Towards the around objects, surrounding
Towards to
objects.
the sun. Understanding? So this is the sun. Okay, and this is the small planet called as Earth. So every point the centripetal force is acting towards the home, guys, towards to the sun only. Understanding? So that is what you have to remember.
Then sun will not produce the centripetal forces, sir.
Sun itself is producing, Mari. Sun is only producing gravitational force. Yes or no?
Yes, sir.
Yes, that gravitational force only exerting always towards to the sun. Otherwise, Earth will fall into the space. Understand now?
Yes, sir.
That force only called as centripetal force. Okay, wow. Yes.
Sir, then the sun is providing centripetal force to the earth.
Earth. Okay. Understand, Mari?
Yes, sir.
Next. Similarly, the motion of the moon around the earth. Motion of the moon around the earth. Now tell me. Motion of moon around the earth. So then here what is happening? Here also what is happening? Here earth is the center and who will be the planet? Here. In a circular path. Who will be in a circular path? Moon will be in a circular path. Now, here who is exerting the force? Centripetal force. Earth is exerting centripetal force. Understanding? Earth is exerting centripetal force. So that is what? Again the same thing. It is also exerting what force? Due to the what force? Gravitational force. Are you clear? Yes, please. All of you.
sir.
Yes,
Yes,
that
sir.
is what. So gravitational force of earth is exerting what force? Gravitational force of earth is exerting what force, guys? Is exerting centripetal force. Understanding?
Centripetal force.
Provided.
Sir,
Understanding?
then
Gravitational
why,
force
sir,
of
you have
earth.
drawn the arrow from the moon to earth?
Mari, moon is, earth is pulling towards to its center. That is what I am saying. Do you all understand, Mari? Are you clear?
Yes,
The
sir.
centripetal force is, see, earth, sun is trying to pull the moon towards to pull the earth towards to its center. Earth is trying to pull the moon towards to its center. That is the meaning of it. Clear?
Yes, sir.
That is this arrow indicating that centripetal force is acting towards the what? Center of the earth. Understanding?
Yes, sir.
That is the meaning. Clear?
Yes, sir.
Okay. Same way. You all studied 7th class, 8th class and all. Atom structure. Atom contains what, guys? Atom contains
Sir, in
what?
the middle, neutrons and
Particles,
protons
molecules.
surrounding.
Everybody. Very good. We all people knows. So let me take atom. So atoms, middle center, who is the present?
Nucleus.
Nucleus. So nucleus contains what? Protons
Neutron.
plus protons plus
Neutrons.
yes or no? Neutrons is present. Now orbits. Orbit, somebody is revolving. Can you tell me who is revolving?
Electrons.
Yes, Agalya, electrons are revolving. So now how the electrons are revolving? Who is exerting the centripetal force?
The nucleus.
Nucleus.
Understanding? That is the third example. Chemistry. The motion of electron around the nucleus. The motion of a electron around the nucleus is a what force? Is what motion it is? It is uniform
Uniform circular motion.
circular motion. Any doubt? Anybody can ask. Yeah, we can call it as cell. Yes, yes, Sanjay, you are absolutely right. KLM cells. Yes, very good. Next. Shall we start next, everybody? Next. In our home, you will be having this circular motion. Anybody can tell me? Uniform circular motion. Every day we have a user.
Fan.
Yes.
Fan.
Watch, wall clock, watch, everything. Hand watch or wall clock, everything. The motion of a tip of our hand, write it. The motion of a, examples these are. The motion of a tip of hour's hand and as well as next hand what? Minutes hand. Next one. 2, 3 hands we have. Next one what?
Second.
Second, sir.
Seconds hand. Everything in a what motion? Continuously they'll be in seconds hand.
Uniform circular
Uniform
motion.
Uniform circular motion.
Clock is uniform
Circular
Circular
motion.
motion.
circular motion. Yes or no? Kishore? Yes?
Yes, sir.
Next, as Mari said, a stone is tied like a Kishore. A stone tied to one end of a thread and is revolving or whistling around a particular path, thread, and rotated in a circular with a fixed end of a constant speed. Then that is also called what? Thread and rotate. Rotated in a circle or circular path with the other fixed point. Other fixed point who is carrying? Mr. Kishore is carrying. Yes, Kishore? Fixed end with constant speed. With the constant speed means what we used to call Lingesh? Constant speed. Performs what?
Uniform circular.
Yeah. Performs uniform. Mr. Silas, understand?
Circular motion.
Uniform circular motion. Silas, Puriyama Puriyada.
Sir.
Yeah. So here who is providing the centripetal force? Can you tell me? Kishore Mr. Kishore is revolving the thread in a circular track. Who is providing the centripetal force?
Kishore.
Yes. Kishore is providing, but middle connecting, who is connecting? That name is called as what? Thread. Understanding? So along the thread only, the force is always acting at every point. The force is acting towards the Kishore. So that is why who is providing the centripetal force here? The centripetal force is provided by the, yes, please. The thread, understanding, stretching the stretching thread only will provide it. So if suppose suddenly the thread will breaks, what will happen? Is it any centripetal force is acting between?
No, sir. It goes in a
No,
straight.
sir.
It goes in a
It
straight.
goes in a straight
So
line.
that is what.
Along with the
Now I am
tangent.
using a new word which you people don't know, but definitely you people will study. Remember that the force exerted by the thread towards to the Kishore, which we used to call as tension. What is to call, Mr. Sanjay?
Tension.
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 Understanding? So tension, not normal tension. This is tension means force. Okay. So the tension due to the stretching in the thread. Tension due to the stretching in the thread only causes centripetal force. So please remember. So tension means what? Tension means force. Understand? Everybody? Sanjay knows already. Okay, very good, Sanjay. Right. Centripetal force is provided by the centripetal force is provided by the tension due to the what reason? Due to stretching in the thread. Stretching in the thread. So if the thread wheel breaks, what will happen, guys? As soon as the thread wheel breaks, what will happen? No centripetal force is exerting because no tension. So that from that point, is it the thread will goes circular motion? Is it will execute the circular motion? If no tension, no centripetal force, is it possible to source the centripetal motion, circular motion? Everybody.
No, sir. It will move
No.
on straight line.
So at that point, what will
It
go?
moves in a
At that
straight line.
point, it will go in a not in a straight line. We used to use a word called as, what is that word?
Tangent.
Tangent.
Along with
Tangent.
that,
At that point, it will fly off. It will fly off tangentially. That is the meaning. You have to remember. Is it okay, wa? Kishore, Agalya, no response at all. As soon as the centripetal force will stops, it will fly off tangentially. So that is what is that. Next, you might be visited the circus. How many of you visited the circus? Anytime circus and all, etc. Please. Have you visited circus? Nobody?
yes, sir.
So let us see that. Till now, how many studied we are? A stone bike, 4 over and 5 we are studying. This is 5. Fifth example, and this is the 6th example. Now, you might be notice it, even YouTube videos you might be watch. A biker is continuously revolving in a circular track. Have you noticed it? Biker or
Sir, in a sphere, sir.
yes.
Yes, sir.
Yes, all of you. So now this biker who is traveling continuously in a circular track. Can you tell me now what is that? He is doing a what? Uniform
Uniform
circular motion. Okay, write it. The motion of a biker on a circular track with what speed? Everybody. With what
Constant.
speed? Constant
Constant.
is a uniform circular motion. Okay, so here who is providing the centripetal force? Anybody can tell? Let me see who will guess. Centripetal force, I want to know. Sir, center nobody is there, then who is providing? Center nobody is there, then who is providing?
Gravitation.
No gravitation. Any other?
Circular
bike.
path.
Think. Circular path
Bike.
never provide. Yes, bike is providing, but of course, bike between what? Road and the tires of the bike. Remember that. Tire and the road only provides centripetal force. Please write. Centripetal force. A writing example is easy, but who is providing is important. Centripetal force is provided by the. So what is the force present between two surfaces? 8th class, you might be remember, when one surface is passing over the another surface, what is the force present
Friction.
between them? All of you.
Sir, friction, that is grease.
Yes, ma'am.
Interlocking.
Yeah,
Friction.
provided by the frictional force. Understand the Pranav? Silesh? Provided by the frictional forces, frictional force between the road and the tires of the bike. Any doubt anybody can ask me. Agalya, clear? Agalya, Sangamitrai? So these are the examples of uniform circular motion. These all are examples of uniform circular motion only. Okay, guys? Please respond.